Welcome back. This is part two of using Inspire to come up with an optimized inner link design. In the last video, I just showed you how I made some of the parts 3D, added material properties, colored them, and such like that. Um, it really wasn't that important if you didn't see it. Um, it's not like this is a main software that you need to use in robotics. But if some people wanted to take a look at it, I kind of made it. Um, you'll notice those who are um, keen of eye that the colors are different and such like that. I've gone through this process before on this part, and so I've saved it at strategic part times. Um, so I'm, working and making changes on files that I've already done before. Um, so that's why the colors are different. You also see that I've kind of refined these brackets a little. Um, the center bracket is a different hard point than the outside brackets now. And I've created these little gears. Um, they're really for show, um, but you'll see I'm going to add a motor to this unit, and I wanted to see visually the turning. Uh, just from a standpoint, it helps me understand everything. In the previous video, you'll see that we made the bumper. If I go to that, um, we made the bumper, the coral, and the rail all grounded. Um, and so now I'm going to continue on. I'm going to add joints. I'm going to add a representation for a gear system, and I'm going to add a motor. And then we're going to add some loading uh, at the end. Okay. Um, so the first thing we need to do is add some joints to connect this thing together. And I've moved to before I was into geometry where we were extruding parts, I've moved to the motion. Um, and you'll see that there's a set of different menus. Um, we'll also be looking at structure when we're getting doing some analysis on the part. Um, there is a 3D one where when you want to print a part, um, it actually, I don't know this menu hardly at all, so some of the students who do more 3D printing uh, would maybe understand these components, it looks like you're configuring the printer bed, you're orienting the part, you're adding supports to it, slicing, not sure why you would do that, and exporting it to, I assume, a file that a printer can read. Um, but we're not going to go into that, just I got sidetracked. um, so what we're going to do first is make some joints. And we're going to do planar parts first. So basically this thing goes through and it selects where it thinks planar parts could be. Um, and actually those are not the ones I want. Um, so I am going to go and let me exit this. and I will turn everything off. And you can see I've named these two. Um, turn on the hinges. Oh, I don't want that gear. Um, and I want the rail. And I want the center hinge also. Middle hinge. Okay. So I'll go back to joints, select parts, select all those. I'm just gonna say all, and it kind of does the find for me. So it shows that these surfaces uh, are are parts that could make a hinge joint, where it's a planar joint. So I'm going to say yes to this one, and it puts a little icon of what a hinge joint should be. Uh, I don't want it there. For some reason, it kind of sticks it in the middle. I'm going to move it over um, and hit OK. And I'm going to make that joint locked. I don't want it to move. And I hit OK. We'll go through and do another one. We'll find again this part. There it is. That puts it in the right spot. I like that. Um, this one. I like that one. It moved it over there again. I'm going to move it so it's in the middle here. And then I'm going to say OK. So now I've got 3 joints. If I was doing this for real, I would name these joints so I could see them better. Right? I'm going to bring in the rest of the materials, or the rest of the parts. And I'm going to, I'll get rid of this one. And this one, there's going to be no joints associated with that. Oh, one of the things I'm going to do is I'm going to make these 2 parts one part. So that is rigid groups. So I select this, I select that, and I'm going to call this, that is the outer arm, I believe. There. And I'll accept that. Let's see, rigid group, outer arm, yeah. So those, basically it just takes 2 parts, and if you want to quickly make them one, without really merging them all together, right? They act as one part, but they are 2 separate parts. And then I'm going to turn that part off, and I'm going to turn that one off, because I don't want joints associated with it. I'm going to go back to the joints, and I'm going to do aligned holes. And I'm going to find, oh, I'm not going to use the selected parts. I'll grab everything now. Okay, there we go. So, I don't want that one. Do I want the whole thing? Yeah, I do want that one. So that made a pin joint. Uh, and this one, again, a pin joint, pin joint. Pin joint just, in a sense, visually, you can see it's got these little cotter pins, so it has 1 degree of rotation, and it can't, it restrains it from moving in the axial of the cylinder, um, versus a hinge could move up and down. Um, Another one there, and another one there. This one didn't show, and sometimes there's geometry errors, and there is a geometry error here. Um, these two parts intersect a little bit. The boss that I created is actually intersecting with the um, pickup I have on this. So what I can do is manually pick the surfaces or the holes, right? A pin is looking for 2 cylinders that are coaxial to each other. So if I pick those two and then hit OK, I get a pin, and I want it to be active, and then I hit OK. So now we have joints on these parts. Um, and these are all the pins. And again, if I was doing this um, without a time constraint, I would name these. Okay. I'm going to bring back everything. And I'm going to turn off the bumper and turn off the coral. And now I want to add a motor. And you can see there's a little motors here. There's actuators. You can add springs. You can do contact. You can see right now, because I haven't designed what this blue part should be, the inner arm. Um, there's, one's going right through the next, and I wanted to do an optimization before I decide what kind of structure I have in here. Also, probably this arm, if I'm being honest, this green arm is probably going to go a bit higher and then come back down. But for right now, uh, it's fine the way it is. Uh, so I want to add this motor. I want the motor to turn this wheel. So select motor, and it kind of says it wants a hole, a surface, or a pin. So the surface is what the motor's going to attach to, and then the cylinder is kind of, what it's got. And you can see it makes a very big motor. These are all the properties of the motor, and one of the things I can do is scale it down. Um, so the shaft radius right now is 20. I think ours is like actually 3. So, setting up the shaft radius kind of um, scales the motor visually. It doesn't, it's just a visual thing. The other thing I'm gonna do is I'm gonna orient the motor to where it kind of should, I think it's pointing in the wrong direction, basically. So I'm going to turn it 180, and then I'm going to it so that it is, oops, I want to move the, there. I want to move it so the point is in the center of that hole. There. So now the motor's there, and there's a little bit of, it's just a visual thing, but you can see it's kind of crashing into it. I think it's fine for right now. I think I can scale it a little bit. Base scale, let's see. Let's do 0.7. Does it do anything? I don't know if it did anything. Maybe it did. But now it kind of looks like, I guess it did. It kind of looks like it's sitting on this bracket. I could make it, I don't know, 0.8. Okay, it's a little bigger. Okay, so there we go. And there's some pre-set up values, so it's 60 RPM, so one rotation per second. Um, I don't want this thing going that fast. I'm going to turn it down to, I don't know, 1 rotation, 6 rotations per minute. That would be like 10 seconds. Let's make it 4. So, and we're going to restrain center line. That's going to keep this gear that I've set up restrained to the center line. And then we're going to hit OK. Okay, so that's set up. I've got my joints set up. And now I just need to kind of set up this gear, right? I don't have teeth. Um, and I wouldn't want to use contact for this. It would be too computationally expensive. So I'm going to put in a coupler. And a coupler just is a kind of mathematical relationship, right? And it wants a joint and it wants either 2 joints or a motor and a joint. And so I'm going to select the motor and I'm going to select this joint. And then it kind of sets up the relationship, right? So when this goes 360 degrees, this goes 360. I know that I made this little gear 25 teeth or 25 radius or diameter. So I'm going to make this 25. And I made this one 30. So I'm going to make it 30. And you can visually see, now you can see that when I put it in, it reversed them. So I put them in the wrong ones. It's got a little feature where you can just swap that. And it kind of shows which direction. When I do the initial run with the motor, we'll see which way this thing's going to go. So we'll just hit OK now. So there is my coupler. And I think we're ready to run. So here we're going to analyze the motion. Active and non-flexible. Fix, oh, So right now, all these joints that I have, if you look at them, they have like a stiffness. Um, and the behavior is default, um, which is flexible. Um, you can also have rigid. Uh, so I'm going to leave it default, but I'm going to select the pin joint here. Add one. And a it can't be flexible with a coupler attached to it. Um, Flexible joints allow you to have multiple joints on basically a rigid part, right? So this one is going to be rigid. So as I was kind of saying, I have, on this part here, multiple joints, and in motion analysis, all these parts are rigid, right? Um, I can set up a flexible body, but to allow the simulation to go forward, um, the joints have a little bit of flexibility. Um, and then the simulation monitors how far these joints move away, right? How much did that spring deflect? And if it's too much, it flags it for you as an error. So anyways, I made that joint rigid. I think we should be able to run now. And there we go. So it's running the simulation and it's showing me the values. Um, and we have it put me into kind of like a play situation. We can kind of see the motion, right? Which looks pretty good, right? I got the general, um, the complete motion that I wanted. Um, and if I look at certain aspects of this now, um, let's look at the motor. So the motor has a torque of 1,000 Newton millimeters, basically. Um, some of the joints, if you wanted to look at them, you could see the forces in them. Um, if you look at some of the parts, you can see how far they're going. And there's other things like one of the things I didn't do. Um, let's kill this. Um, I didn't set up gravity. So, um, forces, I think. Yeah, gravity. They have these little pull downs when you have more than what can be normally shown. They put in um, that. So gravity's one I always forget. Oh, it's defined correctly. Good. I don't have to change it. You can, I could set it to Y or um, X, Z. Oh, wait, Z. That's not Z. Where's Y? There we go. So it's set appropriately for me, so don't have to worry about that. Um, I can go back to the folder, well, oh, results, there we go. Do I need to run it again? I think I can just go back to the previous results. Maybe not. It runs pretty quick, so we can go back and look at that. Now, one of the other things I can do is I can add, I could lock this motor. Let me stop this again. So I'm going to lock it. And then I can apply a force. Or can I? Actuator. I could apply an actuator on this surface here. And that's a displacement actuator. And can I change it to force? Velocity, acceleration, force. There we go. So I can put this to, I don't know, 25 newtons. Or, yeah, let's see, 25 newtons, 4 pounds, 4 newtons per pound. So 100 pounds is 400. So 100 is about 25. So 100 newtons, 25 pounds. There. Okay. Now, just like the motor, if I don't like how big that is, I can just scale. I can scale this by 0.5, make it smaller. Okay. And I can rerun this. And basically, this actuator runs, it has a kind of a standard profile, and it goes up to, I gave it 100 newtons, it goes up in a pulse and it comes back down. Simulation has a standard 10 seconds. I can change these values, but these are the default values put in. So the simulation ran, it immediately started up, and it shows, you know, what what's there. We can see the motor torque is going up to 14,000 Newton millimeters. So you can see you can cascade these loads through, and you can see what forces are coming on specific areas. So if you need to design a specific, say, part of here, and you wanted to get the force, at least to this load, you could, you know, send those, or generate those forces. And you can actually export the forces to a part, right? So you could select this part and all the XYZ forces would be exported. Um, so that's kind of one thing you could do. Um, so that is the motion analysis. Um, the next thing we're going to do is, well, it's 30 minutes. So I'm probably going to stop it here. The next part of this is I am going to set up um, external forces on this claw base and then do an analysis on this part to see what the load paths are in here. Um, and we'll go through that in the next video.